Recording. All right, again, good afternoon, everyone. We'll be discussing Flume, Scoop, and Uzi. And there were few topics which were left earlier. Those are the things which we are going to discuss before we start today's session. All right. All right. So let me start with the first session. There were few things you asked us about. What are those different kind of input splits, right? So the general one, the default one which we have talked about is text input format, where the the lines are read, new line separated, and each record is basically a single line. All right, each record is basically a single lines, and records are separated by new line. All right. In case you want to have a different delimiter than the new line, oh, sorry. Now the screen is visible. I forgot to actually share the screen. All right. So as we discussed earlier, that there are something called input splits, and by default, if you don't specify using job dot set input format, this is how when you're launching a MapReduce job, this is how this is how you specify your format class. Okay, by default, if you do not specify anything using this, the text input format is the default one. And in text input format, you each record is a single line from the text file, and records are separated by new line. And therefore it also provides you a way to change the delimiter. In case you want to do paragraph wise processing, you can put your delimiter as /n/n, two slash n's instead of single slash n. All right. So if you in the config, if you set this parameter, then it will basically help you uh, configure the delimiter. All right. Now, in case instead of reading one line at a time, if you want 10 line, 20 line, or 1,000 lines at a time to be processed, you can specify use n line input format. Okay, in n line input format, you will get those many lines. You can specify the config parameter using mapreduce.input.line format dot lines per map equals to 10,000. Okay, so that is the property it expects in the job config itself. Okay, now this is good. N-line input format is good. Now there's something called fixed length input format. So generally, the way we interpret the input, we basically say in comma separated format or our normal text input format, we are delimiting text. In delimiting, there is delimiter is the one which separates records, but sometimes our input format is in the form of very rigid way, that these many characters are blocked for date, these many characters are blocked for this particular value, and that is dictated, okay, in certain kind of format. This is very much specified. This format is standard. And to handle such kind of input format, basically we need to use something called fixed length input format. Okay. So if our records are of fixed length, then it makes sense to use these kind of format. Okay. Not only the input data can be text, it can be arbitrary binary data. Okay. And in case, yeah, and since you will be handling fixed length, therefore you can set the record length using this. So there's a static method, fixed length input format, which it provides you set record length. And using this config, it sets this record length into the config, and that makes your life easier. Okay. Now, so that was our fixed length input format. There is something very interesting in input formats called key value text input format. Lot of times you will be dealing with the key and the value. Okay. Lot of times you will be dealing with key and the value kind of data. And so each record is basically a key and a value, and the records are broken by new line. Either it can be a slash n or slash r. Okay. So carrier's return is essentially, we call it slash r. Okay. Line feed is slash n. Okay. And each line is divided by key and the value separated by a byte, and that byte can be specified again using a similar property. Okay. And here the problem is, the only downside of this case is that separator cannot be more than a single character. All right. So if you have your key value is separated by equals, then you can specify that way. All right. So key equals value kind of files can be interpreted quickly. Now the next one is interesting. So lot of times you will realize that you are going to deal with lots of small files, and you so much wished that out of these files, some of the files should be operated on one node, some of these files may be operated on another node, and so on. Now what do you do in such kind of scenarios? So you generally form a zip out of all of your small files and then convert it into a sequence file. Okay. So sequence file is a great format when it comes to dealing with large number of files. All right. So you basically create something called a sequence file out of all your files, a single file like a tar. Okay. It provides you, not really. The information in the mapper might come as a binary. Okay. The key and the value can be bytes or can be string or the standard ones. All right. So every format has got different inputs. Good question. Now, so for example, a sequence file is Sequence file input format helps you read a format called sequence file. Sequence file is very specific to Hadoop, and the format of a sequence file is it's a flat file of binary key value pairs. Okay, so this file has got something called a header. Okay, it has got a header in which we specify various kinds of detail, like how is your format specified, what are the various fields, what are their sizes. All of that is specified in the header, and after that there is a full binary data. So to deal with such kind of format, sequence file provides all sorts of methods to Hadoop so that users can process such files. All right. Not really. Every record is not necessarily a file. Every record could be any kind of data. Okay. It can be a file, file as in content of the file. You merged all the files together and formed a sequence file. Just like zip, tar, and other things, it would be a sequence file. All right. So basically, there are a lot of tools which help you convert a sequence file into a zip file into a sequence file, and then let the Hadoop keep on processing these sequence files. Okay. So before you say there's a common use case where you have a lot of zip files from various kinds of say images. You have got lot of images, so you will just form the before pushing it to HDFS, you will bunch all your images together and push it to HDFS in the form of sequence file. All right. Now there are a few more notes. Sometimes you have to read the whole file on one mapper. So you can do that very, very easily by getting the URI of the file. Okay. So the input to such system would be a list of files maybe. And that file you inside your mapper, this code is you can directly read files inside your mapper, okay, or reducer using this way. All right, so this way you can actually read the data from HDFS. Okay, other than that, sometimes you have a lot of zip files, say Apache logs, etc. For that you can use third party splittable libraries which can basically help you processing a gzip file. So there are many input splitters which have come into place based on various formats. All right. So gzip splittable, if you want to use, you can use that one. Okay. Sounds good to you? Although gzip is not a great format supported by Hadoop, Hadoop instead supports Algedo. Okay. Hadoop instead supports Algedo. Okay. So basically the same split. The Algedo, the property of an Algedo, why we use Algedo is in case of Algedo, we are able to split the zipped content and still we can read the content. That is the beauty of Algedo. So Algedo is ideal compression format because it is you are able to split an Algedo and still process it. Okay, so you can use Algedo as well. Okay, so you can use Algedo as well. I mean, in past, mostly we have handled the data in the Algedo. We mention in the config itself that we are dealing with Algedo data, and Hadoop takes care of that part. Okay. All right. So that was about input split. So out of this, have a look at our code which I had showed you regarding input splitter, and you can use either of these formats based on your requirements. Right? Now, the next thing I wanted to discuss, so should we, okay. The next thing I wanted to discuss is big user defined function which we had left. Okay. So basically you can have a look at, so the project is available on this URL. Okay. Let me just create the PDF so that it is available to you. So all you need to do is just like Hive, you need to extend a class called eval func and specify that what kind of argument are you expecting. Okay. And afterwards, I mean, what kind of output you are going to give, what kind of output expected from your function. And same, then you can write a function called public exec, and the input is same for you, a tuple in the form of tuple, and you have to return a value. So what am I doing here? First I check whether tuple is null or tuple size is 0. After that I get the first value, 0th value of a tuple. If the 0th value is not null, only then I convert that into uppercase and return. Okay. So this is a very simple evaluation function that operates on each tuple at a time. And the way you need to do is, after this you will do export and export it as a jar. Okay. You export it as a jar, and then you copy this pig UDF onto the server using SCP. Okay, you can copy it onto the server using SCP. You can see my screen, right? So it's being copied, and once it has done copying, so if you see, I'm basically copying wherever I exported jar to this location and into a folder called asgiri. Okay, it means this is the host, and after the column is the name of the file. Now once you are done with the copying there, you will say go to the pig and say register. Okay, and in the register you will have to tell that what jar do you want to register. So you will basically register whatever jar you have just uploaded. Okay, remember to do it from the same folder in which you have uploaded it, and you say a equals load some data. If you see what is there in this data, if you want to see quickly what is there into data, what do you do? Cat xyz8.txt, right? So you have this data. Perfect. Now load. Now for each, if you notice, is this function my UDF. What is my UDF? It is the package in which we created this class. Okay. B is this. We are iterating over every element of A, and then we are running dump. So in case some error occurs, so you can go to the URL. You can see it is succeeded. Under the logs, you will see all the details which is being published. If you put sysout or system.out, say you write here something like, you know, you write sysout and say printing str. So now this statement would also come here. Okay, here it says sysout 0, but length 0, but it will in case you put some print something, then it will be coming into the logs at this location. All right, so sounds good to you? Sounds good to you? It's pretty straightforward. If you notice, it's very straightforward. Any questions on pig UDF? This was a pig UDF in Java. If you want to use Python or something, I think you can go ahead with the streaming pig streaming example for user defined functions. Great. Now that was our pig. Now here, let me export it to PDF. All right. So you were asking about an example of coprocessor. For coprocessor, for the most important thing is you need to create a coprocessor class. Okay. You need to create a coprocessor class by extending various kinds of coprocessors available in the system. Most common coprocessor which we use is the reason observer coprocessor. Okay, we basically extend that class and then we implement pre-get, post-get, and pre-put, post-put. For those, or every time these functions are going to be called on the table, your your class is going to be called. Okay, every time somebody is going to call get, your class is going to be informed first. Okay, so as you can see, I created a class access control coprocessor which extends base region observer coprocessor, and under this I wrote something called preget and also overridden it. And under this we can basically do all kinds of checks. In the preget itself we can inform that, hey, we don't allow you to access this, or basically these can be used greatly for various kinds of access controls. Okay, similarly you can override pre-put, pre-delete, or post-delete. Okay, or post-put. Just like this one, you can just keep on adding more and more function with an override keyword on the top of it, and then everything will be hooked up properly. Now once you have created the class, you again export the jar, upload the jar near the cluster, and once it is uploaded onto each region server, so once you have created jar, there are two ways to do it. One using this HDFS config, not HDFS, this is HBase config. HBase config. Okay. So you can go to each and every region server and copy this jar into the config folder, okay, as well as edit this file confetchbasesite.xml, and then mention this particular config only without description, only the first two. It says that this is fixed hbase coprocessor region classes, and you can put your class's name comma separated way, okay, and restart your region server. This way you have hooked your code into a region server, okay, for all the tables. Now if you want to get your, if you only want your logic, your code to be executed per table basis, you can define your you can create a path to your jar and then mention it in the attributes of the table, okay. Say here we are creating a table, and after creating a table we are adding the attribute, okay, to the table, saying this is my url, okay, this is my url, and this is the class name, and this is the priority. So these are the three things you can mention, and then it will execute that attribute as a coprocessor. Only remember, when you are setting a coprocessor attribute, the name should start with coprocessor, okay, the name should start with coprocessor. This way, the beauty of this approach is, there are three benefits of this approach. First, you did not have to copy your jar to all region servers. Second, you did not need to uh, restart your node, restart your region server. Third, this only let you put restriction on a single table. It does not bother the whole database. It doesn't impact the whole database. Okay, so preferably when you are dealing with coprocessors, you use the table based coprocessors. Okay, you use this sort of configuration to enable the coprocessor on a particular table. All right, all right. Any other questions here? Any other questions here? All right. So regarding yarn architecture, the basics I have explained. Beyond the basics, we'll not be covering in this. Okay. I've explained the basics. Beyond the basics, we'll not be covering in this. And yeah. So, and moreover, you would not require that. I mean, you would not require that yarn architecture detail too much for your practical implementations. Okay. Okay. I went through the distributed die structure. Oh, you mean distributed cache? Okay. So you went through the distributed cache, map side and reduce side join, but still I need overall understanding and when to choose what. Okay. So basically you use the reduce side operations to aggregate things. Okay. And map side things to basically concatenate or restructure your input, reform the input. That's the objective of map and reduce side. Okay. And but I need overall understanding when to choose what. Okay. I think a better idea would be, let me just make a note of it. Okay. Okay. So see there, when we talk about cache, there are two kinds of cache we are talking about. One is the cache where there is a distributed cache provided by Hadoop so that you can push your jar into the cache and it is made available to all the nodes. Okay, that is one distributed cache provided by Hadoop to you. But outside the Hadoop, the terminology of distributed cache is that it's a sort of a distributed, just like memcached. Okay, memcached is a distributed cache, which means a caching server available on multiple nodes running parallelly, and it divides the data, whatever key values you put in, onto multiple nodes. Okay, so whenever you try to access the key value, it takes you to the right server and gives back the correct value. Okay. So that is one distributed cache. But whenever we talk about Hadoop or distributed cache, it generally means the cache in which you are launching your jar from one machine. Now there are 10 reducers and 10 maps. On all these total 20 machines, your jar has to be made available. And the best way to do is by copying it to something called distributed cache. Okay, that is a distributed cache. And second is your reduce side join and map side join. So which one are we talking about? I mean, I did not get that. So map reduce, it is up to you how you form your logic. Okay, map side join, reduce side join are very specific terms with respect to Hive. Okay, in Hive you enable the map side joins itself. So the map side aggregation actually, not map side joins. Okay. So could you forward me the URL from where you have gone through so that I can clear the doubts, because everybody has come up with their own keywords and that keeps on confusing us. All right, Prashant. Okay. So I'll just go through it and respond to the email, and we'll send put everybody else in CC. Okay. And yeah, or you can put it on the forum. I can respond it there. All right. So I'm just making a note of it. I'll understand what you mean by reduce side joins and map side joins. Okay. Are you talking in terms of pig, hive, or map reduce in general? Which one are we talking about here? Okay. 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 So you were going through the book definitive guide. Okay. Let me make a note. Okay. Okay. All right. Cool. I'll make a note of this. Made a note of this, and then we can discuss it. All right. Okay, okay. So even after reading that section, you have doubts about when to use which one, right? So let me write it down in my own words. If that explains you, it will be great. All right. Okay. If two files are big, then how we can proceed? All right. So, I mean, if two files are big, then you generally follow the way we have done the map. I mean, you should start with the map side joins itself, in the sense that on whatever field we are trying to join, we make that as a key, and then we move ahead. Okay, great. S- All right, all right. So, okay, all right. So that I'll share. So another question is, can you share the doc for HBase on MapReduce? Okay. So the syntax was this. Here, here we have used the syntax. It's just that I'll just put a reference over here. Okay, I'll put a reference over here. Okay, okay. So your next question is that it'll help if you can give an example on map side joins. Sure. I think a better idea would be to actually share the code with you of all the four examples I have given you. The last example, the fourth example of MapReduce, that problem is actually related to the map side joins. Okay, that fourth problem is actually related to the map side joins. So let me see if I can, right, if I can, give you a running example of code the way I have given you a running example of code of combiner, partitioner, hive, UDF, pig UDF. So let me try see if I can give you that one. All right, just a second, let me close the window. All right, so now the next topic which we were planning to discuss today is the Flume. All right, okay. So quite often you will have to push the data from various sources onto HDFS. This pushing the data from various kinds of sources onto HDFS or any some similar source is called data ingestion. So when you are putting the data onto HDFS, you'll be using a tool like Scoop. if the data is unstructured. When I what do you mean what do I mean by unstructured? Unstructured is something like Apache logs. Okay, and that's a very common scenario. So you have been running your servers of website for maybe 5 years. Now you have got humongous data. Similarly, your so the existing data, pushing the existing data is straightforward. But if you are running 10 servers, and every day there is an accumulation of logs. Do you want to run it every minute, every second, or as and when it comes in? How frequent do you want to push this data? Okay, so generally the general demand of people is, let's push it as soon as the data comes in. Let's push the data to HDFS as and when it comes in. So for such kind of a need, when we want to push the data to HDFS as and when the data comes in, you use something called scoop. Okay, you use something called scoop. Scoop is basically a very generic and on philosophical level very simplified tool, where it basically has something called source. And I will, sorry, I've been describing you about Flume. Okay, not the scoop. All right, sorry, big blunder. So whatever I have described just now is about Flume. Flume is used to push the unstructured data to the HDFS. Okay, Flume has got source and destination, and it basically listens to various kinds of data input and then pushes it onto HDFS. We'll describe to you the Flume in a minute. Let me just go through something called Scoop. Scoop is essentially tool which basically pulls the data from any database such as MySQL or any other database which has got RDBMS, I mean JDBC driver. Okay, so Scoop is also open source. It extracts the data from a structured data source, as well as it pushes the data to back to the structured data source. Structured data source means any relational database. Okay, it can also move the data from database to HBase, as well as it can export data back to the database from HBase as well as HDFS. Okay, it supports a lot of databases, and thanks to JDBC, it supports almost all the databases. Okay, so to launch to to launch the scoop, you can basically just log in onto any of the servers and say scoop. Okay, and once you have logged in, you'll see all of these commands. Say help, and there are many connectors available for scoop. Basically, scoop can actually read from almost any database which provides you the JDBC connector. So for the example sake, okay, for the example sake, let me create a database. Okay, let's create the database called scoop3. We say drop database. Okay, or we can say, so we have got this database already, scoop ex3. Use scoop Scoop ex3, show tables. Okay. Now in this, basically, if you're creating a fresh database, make sure that this, why are we talking about these privileges here? This is probably the most important thing which you will not realize if you are doing this on inside the virtual machine. Okay, you will be pretty happy that hey, my scoop experiment worked in the virtual machine, because it'll be on the same machine, and on the same machine MySQL lets you read from anywhere, from the any application. Okay, that means you'll be pretty happy that all of your scoop commands are working, but when you go on into the production, nothing will work for you. Okay, nothing will work. So thanks to this cloud lab kind of cloud lab kind of cluster, that we have been able to understand clearly that when you are dealing with the scoop, you are dealing with distributed computing. So whenever the import from your database to HDFS will be happening, the communication between multiple node will go to your database. So if I have installed my MySQL on Hadoop 1, and after I launch my import query from Hadoop, this MySQL to our HDFS, the request from all the task nodes which have been assigned the duty will be talking to this MySQL, which means these machines should be able to log in remotely onto MySQL. Okay, so if they are not able to log in, then they will not be able to, then your import will fail badly. Okay, then your import will fail badly, very badly. So make sure you have given the permissions to your node. Okay, the way I have given it to all my node, similarly you can also give it. And here you can use a percentage instead of saying all of that. Okay, so make sure you give the permissions. Second, you create the table and insert the data into the table. So let me show you. So our data is ready now. Okay, after we have created table, inserted the data, and afterwards, next thing you should do is you should just take the data. Okay, take this command which says scoop import connect to this database. Okay, and get this table. Okay, and then import that onto HDFS. Okay, now not this. Will it support object database like MongoDB? So for MongoDB, there is another project called Mongo Hadoop. Okay, Mongo Hadoop, this one, which basically let you get the data back and forth from Hadoop and MongoDB. Okay, so since MongoDB, I I think there is a JDBC driver, JDBC driver MongoDB. So since there is a JDBC driver available, you can actually use Scoop as well. But I'm not sure how compatible is the JDBC driver. Okay. Here it is. Okay. So which means you can actually use this JDBC driver with your scoop. Okay, to put import export the data from this. Okay. Now our task has finished successfully, as you can see. Okay, as you can see, let me have a look. Yeah, it has finished successfully. Okay. Mm, which means that we should have a Hadoop fs minus. So there is a widgets table over here. You can see that. Okay. So if I say Hadoop fs minus cat, all right, you can see here that the data has been copied. Okay. So if you can see this, so the data has been copied from our MySQL database into HDFS. Now, what do we want is we want to move this data into Hive. But for Hive, we need to create a table. And to create a table, we will have to mention, for creating a table, we'll have to mention the correct set of columns with correct set of data type. And that is not something possible when you are moving data which has many columns. Okay, so we can actually utilize scoop for the same thing. Okay, also you should notice that there is a class called widgets that gets created. The widgets have been created, this class. It is basically a okay, so it is basically a good way of connecting scoop and HDFS, and this basically gives you a sort of an ORM layer. Of course, that's what I was telling. So yes, this scoop runs the MapReduce for this. Okay, scoop runs the MapReduce for this. That is why I was telling you that since it will be running MapReduce and hence running from multiple nodes, therefore your MySQL should be accessible to all the nodes. Your MySQL should be accessible to all the nodes because it's running HDFS. Okay. Is there any splitting mechanism behind this? Yeah. So no, this means one reducer actually. Okay. Minus M means one reducer. I'll show you. Let me have a look. I think one mapper. I think one mapper only. Scoop man's help. Yeah, it will be I think one mapper only. Scoop help. Right. So here you can see, so this is essentially number of mappers, because you have the flexibility here. Because there's a table which needs to be called from multiple machines, and the whole thing would happen actually inside the mappers, not from the reducers. Yeah, you're right. All right. So here, let's say you have 10,000 lines, 10,000 rows in the table. So based on number of mappers you define, to those many tasks will be created and data will be imported during the map phase itself. There would not be any reduce phase. Can Scoop can Scoop support pushing DB directly to HBase? Yeah, okay. It does support you. Okay, I'll show you that. So number of mappers is equal to number of in splits would not work in this case. Yeah, it would not work. Because see, what's happening is here there is no HDFS file, and we are creating number of map task based on our demand, based on our knowledge of number of rows. Okay, or based on the knowledge of Scoop itself, figuring out how many rows are there in this table. Based on that, this split is happening. We can give, right, we can define number of mappers by ourselves, right? Now, all right, so next step is we were able to successfully copy our data to this particular file. Now the next step is, instead of we manually creating the table into Hive, we can actually say this. Okay, we can say this. We can say create Hive table. Okay, and based on that particular table in MySQL. Okay, so it has created the Hive table for us. So you can see here we are saying connect to this database, you and this table need to be created. Okay, select star from widgets. Okay, you can say drop table widgets, and still we can see. Okay. Hadoop. Yeah, it's there. So I'm trying to drop the table which was already there and trying to create it again. So I've dropped it. Now I'm creating it again. Okay. So we have this. Okay. Now we can say select star from widgets. So right now there are no. So you can see that first what we did was copied the data from MySQL into HDFS. Second step, what we did was we created a fresh table after deleting the old one. We created a fresh table using Scoop itself. We did not have to keep specifying that this is the column, this is the column, this is the column. No, we let Scoop create the table into Hive. But this table doesn't have data right now. To load the data into this table, we can use this command. Okay. Now we can see that the data has been imported. Okay, it's a standard command. Now there were three steps: first copying the data from MySQL to HDFS, then creating a table, third was to load the data, right? Instead of that, what if we could do all of this in a single step like this? Okay, we can see in a single step we could do everything like this. Okay, now it says that the table already exists. Okay, the file already exists, so we can delete this file. You can say drop table, drop table widgets. Okay, and then using Scoop we could, so I'm switching back and forth between command prompt and Hive. Okay, command prompt for running Scoop command and Hive for running database operations. Okay, now the file is already existing, so we can say Hadoop my fs minus rmr and widgets. RMR is for recursively deleting the folder, right? So in the similar fashion, the way we have done is we can also talk to HBase just like this. As you can see, everything is same except for saying create HBase table. Alright, so this is successful and we can go to Hive and check what is there in the widgets. Select star from widgets. So the data has been imported. Now next step is to take the same table and copy that into HBase. Now let me first check what is there in the HBase. says my HBase table. I'll just drop this table, disable. Oh, I need to put a single quote around it. I think it's delete only, right? What did we do last time? Oh, it's drop. Disable. Done. Now we have already disabled the table. Now let us try to create. So what we are trying to do is we are trying to create my HBase table based on the widgets table available there, and we want to say that insert everything into a column family CF1. Okay, so oh, I got it here. All right. So this way we can actually import the data from MySQL. So it says that import everything into column family CF1. We can define a more sophisticated column mappings using various options provided by HBase. Okay. You can say column family will get these columns, column family 2 will get these columns, and so on. Okay. So that also we can do using scoop. Right? Now it is doing something, and you can see here there is no reduce actually. It's only map, right? Also, if you want to check what has happened, let's see what goes on. So this is that URL which this process has given, and here there are reduced total number of zeros are reduced, and there are three maps. Okay. Okay. Now the next step would be to copy the data from Hive to MySQL, which is actually straightforward, but it requires a little more hard work. So Scoop doesn't give you that incremental way. Okay. Scoop doesn't give you the incremental data push into Hive. Okay. The only thing I can maybe think of is I don't know. Maybe keep a counter of what all has been copied based on IDs or something. Yeah, you can actually define a subset of total data by a particular method in here. If you see scoop help, and there will be something called scoop help import. So there was something called a query. Yeah, here it is. So there is something called minus e query. Import the result of SQL. Okay. Next thing is that we have got a file called sales.log in the HDFS. Hadoop fs minus cat. Hadoop fs minus cat. All right. Can you hear me? Okay. Okay. Yeah. So we can customize the query, and I was actually trying to show you the sales.log, and my connection has hanged. So maybe I will just terminate my connection. In case you get your connection terminated, connection hanged like this, you can basically say tilde and dot. Okay. See, it got disconnected now. So if you press tilde and dot, you will get the, will get disconnected from the server. Okay. Tilde means this one. So tilde and dot. This one. Okay. So I can say Hadoop fs minus cat, and I can say sales.log. So let me go to the folder which I had created. Okay, so it is there, the file is there. Next thing is we will create a table in Hive. Okay, let me see, show tables, and select star from sales. It is there correctly. Next thing, MySQL minus u root. Can we configure key for HBase in scoop on data push? can we configure key for HBase in scope on data push? Data push as in, I did not get your question. So when you're moving data from HBase to MySQL or from MySQL to HBase? So do we see any table called sales? Okay. So we already have a table in Hive called sales. We have loaded the data already. Now the next step is we create a MySQL table called sales and select star from sales, show tables. Okay, there is nothing. Okay, good. So the data is not there in the say this database. What we can do is now from the command line we can say, so we can say table sales and okay. So it is basically now pushing the data into the database. Here it says scoop 3, use scoop 3, select star from sales. Okay, so the data is there now, already there actually. Oh, it got duplicated, you can see that. Okay, so the data got imported, just that we did not delete the data, it got duplicated. All right, so can we configure key for HBase? Yeah, you can configure key for HBase, definitely. Okay, you have a look at scoop help import and you will get all the details of the various parameters which it provides you. You can see that. So whenever you're importing it, you can say HBase row key and this is my column. Okay, sounds good to you? All right, so let's talk about Flume. So we were able to successfully import from HDFS into Hive, sorry, from MySQL into Hive, MySQL to HDFS, and from Hive to MySQL, and from HDFS, sorry, from MySQL to HBase, and back and forth. Okay, okay. So all the so you should actually try out all of these commands by yourself and by creating a different database name in MySQL as well as different folders in HDFS and HBase. Okay. So all combinations basically on one side is MySQL and on other side is Hive, HDFS, HBase, So you should try all these examples. So there will be there will be total number of how many? Six combinations. Should try. Okay, three these and three these. Okay. Okay. So basically, H catalog is something which Hive provides to the other systems. Okay. So Hive provides as a service of metadata to all other systems which want to organize their which basically want to use sort of a metadata service. Okay. So the way to query and other stuff, they can utilize Hive service which is called H catalog. Say pig wants to connect to read the file and store the metadata, then they can actually pig can actually use Hive, but although it doesn't, but Hive provides all these functionalities to various application in the form of H catalog. Okay. So one portion of Hive is made something like a service to all the other products, and that portion of which handles the metadata as in columns and other information about the database table, that is what is known as H catalog. H as in H capital catalog. Okay. Okay, so let me just make a note of this point so that next time I put it in the slides itself. All right. So that was easy. That was easy when it comes to structured data. Even if Scoop did not provide you, you could have done it by yourself. Just that you would have to write a MapReduce code to read. Okay. Or even if your data is smaller and you are fine with import on one node, say you have 100 say 10,000 rows. Okay, maybe 100,000 rows, a single node will be sufficient for doing that kind of job. Okay, but if you have more data than that, then probably doing it in a distributed fashion is a better idea. Similarly, if you have got huge number of files locally, okay, or you have got network file system already in place which has say three servers containing your data. Actually, if you want to copy all of this data to Hadoop, a better idea would be to use Hadoop dist copy rather than Hadoop copy from local. Why? Because dist copy distributes the load onto all nodes one by one parallelly, so that not a single node in the cluster is loaded, as well as it improves the performance multiple times. Okay, so so similarly dist copy or scoop, they all behave in a distributed fashion. All right, now if you have unstructured data such as Apache logs, such as your Twitter data in JSON format, you would use something like a Flume. Okay, let me take a break for 10 minutes and come back at 3:42. Okay, then back by 3:42 p.m. IST. I'm back. Are you guys back? Should I start? Can you hear me? Should I start now? Yes. All right then. So let me turn off my phone. So quite often, in case of big data, you have to continuously move data from one location to another, even if there is no structure involved. This data can be of any format. Okay, these can be movie data. These can be various Apache logs. It could be Twitter sentiment data, and these could be CSV files or anything. So you have to continuously move data and connect various machines to take the data from one place to another in a distributed fashion, and take it finally to your HDFS. All right. Now here, and it's remember it's sort of one way when we are using Flume. Okay, it has got source and sink. Source is the so every Flume pipeline or every Flume agent, when we define an agent, so in all the machines we run one agent in, or maybe more than one agent on a machine. So every agent has got a source and a sink and a channel. Okay. Okay. Now let me first describe basics of Flume. Flume supports a large variety of sources, including tail. Tail is tail minus f. Can somebody tell quickly what is tail minus f? What does the minus f flag do? If tail basically prints last 20 lines, last 10 lines of a file, tail minus f, what does tail minus f does? What does tail minus f do? Anyone? Yes? Shows newly appending data live. So as and when the data is appended to the file, tail minus f reads it and shows it in real time. Okay. So when we are using Flume, we can use the sources like tail minus f, which means even if there is a file in which the data is being written, we can use tail minus f kind of commands to read the data and push the data to HDFS. Okay, that also means that we are going to push the data as and when the data comes incrementally, right? Similarly, syslog is a unique way of creating logs. It's a daemon. Okay, so from the syslogs you can push the data to Flume, all right, as well as, or you can shut down syslog on your machine, start Flume instead of syslog, and anything which is being logged, which was be going to syslog earlier, will start going to Flume. That is something interesting. Okay, log4j. Now, the way most of the Java applications log their error is via log4j. Log4j has got a philosophy called appenders. So there are multiple ways, multiple kinds of appenders available in Java. One of the appender which is available recently is a Flume appender also. So when you're configuring your logging in the Java application, even after the system is hosted and everything is working, you can actually add one more appender to the configuration file, saying that any log that comes in, one copy of it should be sent to Flume. Okay. So as well as you can write your own logs, you can write your own new kind of sources and start pushing the data. Okay. Flume nodes can be arranged in arbitrary topologies. Okay, each node or each agent, you call it, basically connects source and the target and the channel. Now the source can be the target for some other agent, and the target can be the source for other agent, right? This way you can chain multiple Flume agents together. Also, every Flume agent can have multiple sources as well as can have multiple targets, right? So let's demonstrate a simple Flume example that should be good enough for you to take it further from this point onwards. So let's launch a daemon at 4444 port, okay, which listens on this particular port, and whatever you type at this particular port, whatever services, whatever clients will be talking to this port goes to HDFS. That is the objective which we want to do here. Okay, now let's go over here. So you can see that we have got configuration here, and we have already mentioned everything here, right? So we have got A1 is our channel name. A1 has got a source R1. The name of the sink is this, and channel is this, right? Now we describe our R1, okay, in this manner, and we describe our HDFS cluster sink this way, and we described our channel here. Okay, also we told channel the about the about our uh, about our sync. Okay, we told the channel about our sync. Okay, as well as we told our sources that this is our channel, we told our sync that this is our channel, right? So first we configured agent that we told that agent, your source is this, sink is this, and channel is this, and then we described e- each of the components in detail. Okay, R1 sink, R1 SDFS cluster sink, and C1. Afterwards, we told R1 that you have to write to this sink, uh, you have to write to this channel. We told the sink that you have to read from this channel. Okay, in the last line. So this way, everybody knows everyone now. Okay, now sync knows who is its channel, and sources knows who is its channel, as well as agent knows all the three components. All right. So as you can see that our sync is essentially of type HDFS, and this is the URL. Okay, this is our URL. So whatever we write over here, it will be going into this folder. So before we create more any confusion, let's just delete the data whichever is there already in this folder. Okay, here let me just go and say Hadoop fsls this. Right, now we'll just delete the last folder. Right, now it is there, deleted. All right, that web data has been deleted now. So we have created a configuration file connecting all the things together. Also, our channel is in memory channel. There are multiple kinds of channels available, and this memory channel will be connecting the source and the other things together. The benefit of having bigger channel, if you increase the capacity of channel, is that more elements can come into this channel. Okay, and that will increase the efficiency because the chunk which is going to push into HDFS will be bigger. Okay, the chunk which is going to be pushed into HDFS is going to be bigger, as well as the rate at which the data is being read from the source will become bigger, faster, but it will consume more memory. All right. So that is why you always have to maintain a sort of a balance on the capacity of the channel. All right. Now that is okay. So let's go into this particular folder where we are going to keep it Asgiri Flume Web Data. Asgiri Flume Web Data. Asgiri Flume. Now web data is not there. Okay. Now let's try to start the Flume daemon. So this agent is essentially going to call. Let it run. Why it is so slow today? Now this agent will launch the source which is of type. The source is of type netcat. Does anybody know what is netcat? The nc command. Do you know what is nc command? So nc is the easiest way to create a server. Okay, nc is a quick way to create a server. It starts listening to a particular port and on local machine. Okay, So it says that configuration file does not exist. So NC is with NC you can quickly create a server and start listening to a particular port and save the data or either just echo it to the user. Yeah, Flume can run on Windows. All right. Now, so which means now we are able to connect to, we should be able to connect to this particular port. Okay. And whatever we type here, okay, we say whatever we type here, let's say can, let me just copy your names and put it here. It is being written now. All right. Now, so you can see the data is coming in binary format, although still the strings are visible. You can see that. You can see. So the data which is being pushed is in the binary format, and you can use the long writable or Apache byte writable to read it and then decipher it. Okay. So this way we are able to successfully create our Flume agent. Okay. So you can use Flume agent to push the data across the network and make a network of all the Flume agents. All right. Sounds good to you? Now, there's another component called Oozie. Oozie is basically a workflow system to manage Apache Hadoop jobs. Now, you saw that we used Scoop and we wanted to run, first create a folder, then create a file and do lot of things before we reach to our final stage, right? So Oozie is a workflow system which gives you the ability to manage the jobs. Okay. Other than executing a job like Apache Ant or you like Maven or like Make. Okay. So you basically define your format in that sense, and then you submit it to Oozie. Oozie executes it. So other than executing on demand, Oozie goes one step forward and provides you something called coordinator. Okay. Coordinator is a scheduler which runs your jobs periodically based on the data, based on periodically or based on the data availability. Okay. So an Uzi is well integrated with the rest of Hadoop stack and is quite scalable and extensible system. So this is how Uzi is defined. Okay. So I had described to you a directed acyclic graph. Is everybody clear about directed acyclic graph? So Purushottam's question is, Flume supports structured and unstructured data. Then why did you use Scoop? Flume basically supports a very unstructured data. If you see the data stored in HDFS was in the form of objects, okay, that can be interpreted by normal way by using programming and then convert it to the the structured data. The problem with Flume, or you can say that there is a little bit of difference. Flume provides you the data in the real time push. Okay, you leave the Flume agents running across the cluster, and they will keep on pushing the data incrementally. While Scoop is for batch wise job. Okay, Scoop is for batch wise work for import and export between databases and Hive and HBase. All right. So I hope that should be clear. Is using Flume, you cannot push data from MySQL into HBase. Okay. Sounds good, Purushottam? No, I'll wait. Okay. Okay. So are you guys clear about what is directed acyclic graph? So I was describing you earlier about how the dependencies we create. So have you guys worked on Microsoft project or Apache Ant or Maven or Make, any of that? Okay. So basically when we say we have 100 things to do, okay? And out of these 100 things, we figure out a dependency saying you can only do this if you finish these three. And then you can do that when you finish this. So when you create that kind of dependency graph saying this depends on this depends on this, we call it a directed acyclic graph. Why? Because it has it is directed, meaning B will start only if A finishes, right? It is directed. It has no cycles. If it says that B will start only if A finishes and A says that I'll start only if B finishes, then there is a deadlock. Okay. So, so to define this kind of graph is quite common when in the computing. Okay. These are called directed acyclic graphs. So project plan is one such example where we create a directed acyclic graph. In this, it says 5 depends on 11, 11 depends on 10, and 10 depends on nobody, which means 10 will be executed first, then only then 3 will be executed or 11 will be executed. If you want to execute 5, first 10 will be executed, then then 9 and 10 will be executed and 2 will be executed, only then 11 gets executed and then 5 will be executed. So based on this diagram, okay, let me just make this a little bit bigger diagram. So yeah, now it's if you look at this diagram below, right, you can see that if we want to execute 5, we say execute 5. The order is going to be execute 10 comma 9 comma 2 in parallel, maybe in parallel. Okay, execute 10 9, and once these all three tasks are done, only then execute 11, then execute 5. Okay, so this way we can solve a lot of problem. Imagine, imagine that you want to execute your MapReduce job. Okay. Now MapReduce job depends on depends on scoop task. Okay. And scoop task depends on depends on some uh, some let's say addition of few data into MySQL. Okay, so it's a typical story of any project that we will first do some cleansing of our MySQL data, then we'll run as scoop and push the data into HDFS. Only then we will run MapReduce job. Okay, so which means that every time we have to execute MapReduce, we have to make sure that all these tasks are executed. So instead of you taking care of such things, Uzi does it for you. Okay, Uzi does it for you. Now let's have a look at it. Okay, now let me go back to the UI. All right, so Uzi provides you this kind of workflow XML for writing the job. Okay, have a look at this. What does it say? This is essentially a workflow for doing the word count. Okay, so when you are defining a job, a task, a workflow, basically when you're defining a workflow app, you define a node which says start. So this becomes the entry point for your workflow, and it says that as soon as you start, it goes to a action called word count, and this is the action whose name is word count. Now what does it action say? It is essentially a map reduce task. Okay, it is essentially a map reduce task with all these behaviors. Okay, all the definition which is mentioned here, it shows you this is some variable which we are using. The name is job tracker, name node. These variables are coming from the configuration of HDFS. So you can simply mention these variables. And after that, you will specify all the configuration saying this is my mapper class, this is my reducer class, and whatever you defined using job. You remember when we were working on the map reduce example in Java. So whatever we defined in the job configuration, those are the parameters you need to provide here. Okay, and we specify reducer, we specified mapper, we specified map_red input directory and output directory. Okay, that's our configuration. This is our configuration of of MapReduce job. So once this MapReduce job finishes, what is it supposed to do? So when the workflow started, it started word count. When word count, we entered into word count, it executed MapReduce. Now when it finishes, we go to end. Even if there is an error, we go to end. In case it gets killed, the whole process gets killed, you display this message. And the end is end. Okay, its name is end, which means it's the end of the cycle. Okay, so this is how we define the workflow of Uzi. Okay, now you can have a look at it here. You can see this. There are other tasks such as fork. Okay, there are other tasks such as fork and join. When we say start my first job is MapReduce or something else, and After first job finishes, it says go to fork. Okay, to fork. So fork is essentially having two parameters called path 1, path 2. We can keep on adding more and more tags, and then all of these tasks, second, third, or even if we have 5 tasks, they will start executed in parallel. Okay. So second says some other map reduce or something else, and third is something else, and so on. Okay. Now, once that finishes, second and third, it goes to the final job. Okay. Join means it says okay to join at both the places, and once that finishes, the join finishes, it executes something called final. Execute something called final, and after final finishes, it goes to end, and so on. All right. So this is how you configure, you create a job. Okay. All right. Now let's have a look at what are the various kinds of Uzi, what kind of various kinds of examples are provided at Uzi level. All right. All right. The If you want to try out, you can run this example as it is given. All you got to do is first copy your zip file onto the server. Okay. And then open that zip file and copy from local the folder containing all the details. So this is an example where you want to run from the command line. Actually, you can run from the server itself. Okay, let me just start this. So if you want to run from the command line, you can use the syntax. Otherwise, you can run from the UI without configuring anything. Okay. But generally, doing it from command line is little bit easier. Okay. So is this clear to all? All right. So from the UI, you can go here to Uzi editor, and you can go into workflows. Then you can create a workflow from here. Say my example workflow. Okay. And out of coordinators workflow, and this is my example workflow. Let it come. It just come. Now, out of it, we could say that this is my map task. This is my map task. Okay, as well as we could say that uh, uh, let's say I want to execute some command. So if you want to drag and drop here Java, you can specify your jar name. If it is not there, you can specify it correctly. After you are done, you keep on adding all the properties, and properties names are same as our usual one. Okay, property names are same as this diagram whatever we are showing here. Okay. Okay, now once you're done with that, you can say done, and then when it will appear here. Okay, so let me say my mr. Okay, and then we can say, okay, so it has been done. We can add property here saying my MapReduce class. We can say as easy dot, what was that name, mapper wrapper. Okay, and say done. So now we have got one MapReduce. Okay, similarly if you want to do streaming, we can define a job of streaming, and we can define, we can add our properties to it, the files which you want to add. Okay, mapper say wc, not wc. What was the mapper, what was the mapper, it was sed substitute space with new line and so on. Okay, and reducer was unique minus c. Okay, so it's a simple streaming example. Okay, now you can see that these two can be executed in parallel. Okay, if you don't want to execute them in parallel, you can bring them to this side, and you can see that. Okay, so this is a very nice UI in which you can define your workflows. All right, so it will basically execute both of them in parallel and then finish. All right, so you can use this in a very flexible manner, and once you are done, you can go to your workflows and select your workflow and say schedule. Okay, that will schedule your workflow on a frequency. Okay, my runner. Okay, we can say, after that we can define how much, what is the frequency do we want. Okay, and once we have defined our frequency, say that we can say that what you know okay, we can define the input data, whatever input is required. Okay, whatever input we require, and that's all. Okay, so basically our coordinator can depend on some data, because mostly whenever we are launching any job at my Hadoop cluster, we will be basically reading some inputs and then taking some decisions. Okay, so every time it runs, it will read the input and then do the job. Okay, so this is how you basically take the work on your cluster using Uzi. Okay, so you can use Uzi for doing all of this, as well as if you want to configure it, you can basically create full XML, save it in your configuration file, then start running. Okay, you can try both of them. All right, there are these kinds of Uzi actions available: running MapReduce job, running streaming job, running any Java program, running any pig script, running any hive script, running scoop, running shell command, then SSH. What does it mean by SSH? Running any command remotely on some machine. Okay, this CP is distributed CP. As I told you that whenever you are copying a lot of data in lot of folders, you use this dist CP. FS is usual SDFS command for various things like make directory and all of the file operations. And then email is for sending email and so on. Okay. If you already created a workflow, you can call that sub workflow here. And all of this is available in UI. And if you are not comfortable, if you are happy with this, okay, if you are happy with the UI, but what you want is you want to see the XML of the particular workflow, then you can see the XML. Okay, let it come. Right. So that is pretty much about Uzi. Okay, try couple of examples of Uzi by yourself, and that is going to be very important for you. Okay, so that was Uzi we discussed. Let me So let's start the discussion about the project. Okay, let's start the discussion about project. All right. So we discussed about three things today, four things so far. First, we discussed about the things which we had left. One was what are the various kinds of input splits available in industry. Then we discussed something called pig and pig Latin. In the pig UDF specifically, user defined function. Then we discussed something about H-base coprocessors, and afterwards we discussed about Scoop, the importing exporting data from various combinations, and then a live example of Flume, and then Uzi with the whole workflow, the examples. Now, all right. So now I want to basically we are all through with the uh, you know the topic wise discussions. Okay, the topic wise discussions are over. What I want to do is as a project we want to do this. Okay, we want to do a analysis. So this is your project, and in this project we will be doing a sentiment analysis of the data which we downloaded from Twitter. Okay, we were Okay, so in this document you download the sentiment files from the server. Okay, these are the sentiment files which are available from S3. And after that, once you download this data from S3, upload the you unzip it. After unzipping, you will see a folder called upload.zip. Using Hue, you upload it into HDFS. And after you upload that into HDFS, okay, you will see that you will see uh, hive dot in the in on the server you upload it using zip file. Okay, you upload it using zip file, although I have already uploaded it onto a folder called, you can actually utilize that one also. Okay, so this is the project document which I've just shared. Why is it so busy? Okay, so I have copied the data into a folder called SENTI. I think that is inside my folder here. In this folder, the data is available already. Okay, you don't, you wouldn't really need to. Okay, now once you have done that, okay, oh, copy these hive queries onto your folder. I will say like this: student at hadoop1.nobigdata.com colon your, here replace this with your name. Okay, so that this will copy hive ddl to this folder. Okay, I'll show you this file, hive ddl. Okay, so this is the SQL. I mean, take a note of this SQL clearly. Okay, put put your put your login here. So basically this is, we are going to use hive to do the sentiment analysis. Okay, so first of all move the sentiment data onto the server. Okay, and after you move the sentiment data, it should be it is already available, it is, I have already done it under this folder. Okay, so okay, this is optional, as data is already available in this. Okay, data is already available in this. All right. Now, once you have imported data, you use your own database name, and after that, create an external table which represent the tweets underscore raw. And tweets underscore raw is basically our folder. You put your our folder name here. Okay. This will be user, student, and something something. Okay. This folder name. Okay. Now let me so okay. Now once you've created Twitter raw, which is over this particular uh, data, also note that if this change is not there, okay, all right. Now once you have done that, okay, then the next step is to basically create another table called dictionary over our data, then create a time zone over our data, then create a tweets simple. Also note here that we are using a row format called JSON Survey. Okay, remember the serializer, deserializer. Before that, add jar in the beginning itself. So open your Hive, run this command add jar, and then use your own database. If your database doesn't exist, create your own database, then create one table called twitter underscore raw, then dictionary, then time zone underscore map. Okay, tweet simple is also one table, okay, which is basically a view. Tweet simple is basically a view on the top of tweets raw. After we have concatenated the date, we have casted the date into a proper date time. Okay, and then we are doing a basically converting tweets into country. Based on time zone, we are adding the country. Okay, once we have done adding the country into our tweets clean, okay, we compute the we break down the sentences after converting them to lowercase into one word. Okay, and so basically we do the explode. If you remember, we gave an example of Hive where we exploded the sentence into words. It's the same thing. And then we join L1. Okay, we join basically L2. L2 is a view over L1 after exploding the words, and we join L1 with the dictionary. What does dictionary contain? Dictionary basically contains the sentiment values of various words. Okay, whether it's negative or positive. Which one? No, tweets are simple. We just defined, right? Dictionary, time zone, then we create tweets are simple, right? I didn't get your question, Karthik. So after tweet.simple, we created tweets.clean on top of tweet underscore simple. After that, we created L1. L1 is basically we exploded the word into sentences. Then further we did, couple one more translation. Here we converted it lower this. Then a function called sentences. We exploded that, and then we had left with this. After this, we computed. Okay, basically this is the command. And after this, we computed this polarity, negative, positive, and at the end of it, we will have a clear idea about the sentiments here. Okay, you can do that. All right. So at the end of it, we will have the sentiment here, Twitter SBI, where we have one column called sentiment, which is 0, 1, or 2. 0 means negative, 1 means positive, and 2 means positive, and 1 means neutral. So we'll have all the things which was there in the tweets at the end of it, meaning tweet, what did people say, I mean tweet ID, what did people say, then country and time zone, plus we'll have something called sentiment, whether it's positive or negative. Okay, so after that, once you have done all of this, now you are ready for presenting the sentiment of individuals across the globe. Okay, you can represent it geographically, you can represent it multiple ways, but prepare you are able to prepare your various kinds of simple dynamics on top of this. Okay, so here I am looking for, I have further brought down my query to further three words, Iron Man 3. Okay, out of the full one. Okay, and then, right, so have a look at the query, have a look, try to understand the query, what does query do? And after the query is done, you try to connect your Excel, okay, by installing ODBC kind of driver, okay. There is a hot and work ODBC driver which enables you querying any Hive server. All right, it enables you querying the Hive server. You can then represent any data in Excel sheet using Hive. Okay, all the steps are available in this particular document. All right, so go through these documents. In case you do not like it, okay, in case you want to do it in pig, feel free to do it in pig. Also, if you want to prefer it, because right now, because all of you will be doing things simultaneously, so cloud labs might get busy and you might not be very happy with the performance right now. Okay, so you might try out the virtual machine. Okay, lots of students actually prefer the virtual machine for their own project, that gives them more confidence, but I am okay with running it on the server as well. Okay, so basically, the idea is that no matter what, you should get a hang of computing the sentiment data analysis. Okay, you should be able to do this sentiment analysis easily. At the surface, here it looks like it's a simple SQL query, but by the end of it, you will realize that it is little difficult to churn the data from JSON to various formats, and and then compute do a lot of basically string lookups. Okay, so go through this file. Okay, this file will be available in the last session. I'll update the session, and then you can use this one. Okay, and then you can present the data on the map howsoever you want, and there are many things you can do. Okay, in case you're interested in doing in pig, let me know. We can work together. Okay, any questions for me? So go through this document, which will be available now. I will make it available in the ninth session. And if you have any questions, feel free to drop me an email or leave your questions at forum. Here there is something called forum. You leave your questions at forum, In case you have not provided a personal email ID, please provide us the personal email ID, so that we tag your account which is created at No Big Data with your personal email ID, because the account with us is lifelong. Okay, account with us is lifelong, which means if you want these videos in future, then you can access these videos in our No Big Data forum. Okay, and if you have any questions, feel free to reach out at Hadoop at No Big Data. Okay, you can reach out to Hadoop at No Big Data. That will be better. And this is my personal phone. Okay, but prefer to drop an email, because if you drop an email, I can quickly look up things and answer. All right. So you have to submit. Yeah, the videos, the presentation, all the assignments, everything will be lifelong. Okay, everything will be lifelong even after this. The only thing is the Cloud Labs access will be curtailed after you finish the project. So there are 15 days maximum from today, and you can see the deadline actually on to. Let me first check where is. Okay, so we just have to shift this by one day. Okay, so here the project last submission date is February 4. Sorry, assignment submission is February 4th, and project last submission is February for 11, 2 weeks basically. Okay, so let's stick with that. Okay, so all of the please feel free to ask questions at the forum and contribute at the forum. Okay, and I will also contribute, and our other student also keep on asking and answering questions. All right, and if you have any doubts, anything, you just drop us an email and at Hadoop at No Big Data. Okay, and feel free to drop me call me up in case you are stuck. Okay, so that's all right. So in case you are in case the Cloud Labs is not working or is overloaded, or if you like to do personally, download the Hot&Works virtual machine. Okay, that one is quite efficient and fast. It requires less memory and space as well. And last time around 2 months back, I checked, it was better than others. But right now, I don't know. Okay, so all right then. Thank you very much. It was a great session, a great set of questions. It was a great session and great set of questions. All right, and feel free to ask any questions. Connect with us, and we take proud in answering question. We try our best to answer the question as much as possible. And if you have any friends, refer them to us if they want to learn, because ITC is probably our fourth business customer. Otherwise we generally give only the retail trainings. Okay, and all right, so feel free to connect. The website name anyway, is nobigdata.com. Feel free to connect your friends if they are interested. All right, and also there'll be a questionnaire submission from my side. You can fill that up. Okay, probably Anjana would be sending. So on-site trainings we have kind of dropped. Earlier we started with on-site for two reasons. First, everybody's candidates are spread across globe. Second, the performance of offline candidate was bad when we observed in our system. Okay, They hardly finished any assignment. So we prefer to give it online. Okay. And second, making a expert available locally is a very big challenge. All right. So so your question, was I able to answer your question? I mean to say that on-site training as in physical classroom training. Do you mean to say a bigger project, bigger training? Also, we have one more thing. In case you have done really well in your assignments and you really want to work on a bigger project, bigger as in a project which involves real time work, and okay, you want to be part of that, we can help you out with that. So we have a separate stream of work that keeps on going, okay, in which we take up some industry work and get it done. Okay, so in case you show a commitment, if you in case you have done really well in the quiz and everything, then that option is I mean you can opt for the option for a longer project, I mean a project of say 2 months or 3 months. Okay. All right, then thank you very much. Please I mean give us the correct feedback. Okay. All right, thank you very much, stay connected. All right, bye bye. It was a great session. Thank you, Chaitra. Thank you, Nasruddin. Thank you, Pratik. Thank you, Satyanarayan. Thank you, Tuntun. Thank you, Prasant. Thank you, Sasikant. All right. Bye bye.